Hey everyone, today we're going to learn something known as the Pascal's triangle. And as you can see on the screen, this is a leet code problem. It's quite interesting actually. And this is what a Pascal's triangle looks like. You'll notice that there are ones on all the corners from the top all the way going down till the left. There is a one here and all the way going down to the right. In the middle, there are elements that will figure out what they are and how they are calculated. So as you can see, this nice animation is showing you that 1 plus 1 is added together to give you the number over here, which is 2. 1 plus 2 is added together to give you the number here, which is 3. 2 and 1 becomes 3 here. And as you're going down, 1, 3 becomes 4, 3, 3 becomes 6, and 3, 1 becomes 4. I hope that helps you understand what a Pascal's triangle looks like. How are we going to write this in code? First, let's understand what we're trying to do. Each of these can be thought about as one row of the triangle. So in the first row, it's very simple. There is just a single element, 1. On the second row, there are two elements, 1 and 1. On the third row, there are 3 elements, and the first and the last elements are always 1, like in every row, and the middle element is found by summing the values of the previous row. So you see, so the only way that you can write this is by going one step at a time and trying to figure out what are the values on a certain row, and then you can use those values to get the values on the next row. All right, so let's go ahead and look at a few more slides to figure out how we can think around this problem. All right, so this is an example where we have a little bit bigger Pascal's triangle. So it is up to 1, 2, 3, 4, 5, 6, 7, 8. 8 levels. And let's see. If you think about coding this and you're like, hey, I want to figure out the whole triangle up to a certain level, you could have a variable like I that basically takes you from 0 till 7 in the case of 8 levels. So think about it like that. At every level, whenever I is equal to whatever it is, you're basically figuring out what each of these values are going to be at that level. In other words, at each level, you are figuring out what are the arrays that you basically need at each level. If you look at the first level, it's very simple. The array has only a single value 1. On the second level, you have 2. On the third, you have 3 of them, and so on. And let's think a little bit more. In order to figure out these values at any level, you need to know what are the values at the previous level. However, for any level, the first value and the second value are pretty straightforward. They are 1. So think about the algorithm that you're now thinking of writing. You are going from I is equal to 0 till maybe I is equal to 7 or whatever you have as your number of levels. And at each level, you're first creating a new array. You're putting in ones at the beginning, at the end of the and at the end of the array. So you see, that part is easy. And then you need to figure out what are the values in that array in the middle of these two ones. And those can be figured out only by knowing what was the array that just came before this. So you're basically going through that array and then you're summing these values and putting it into over here. So again, let's look at this. In order to figure out I is equal to 4 has this array associated with it at this level. When I is equal to 4, we put a 1. We create a new array, we put the 1 in. Then we go through the array for I minus 1, which happens to be I is equal to 3 in this case. And then we go till the end of the array. And then what do? We say 1 plus 3 became 4. Let's push it into this new array we just created. 3 plus 3 is equal to 6. Let's push that into this array. 3 plus 1 is equal to 4, and let's push that into the array. After that, you all you need to do is put a 1 at the end of your array, and now you have this, right? So this problem reduces further to figuring out not the ones at the beginning at the end. That's pretty straightforward. It reduces further to figuring out what is that sub array at every level, which is figured out by the sum of all the values before that, right? So 2 is gotten from the previous values, which is 1 plus 1. 3 and 3 are gotten from the values 1, 2, and 1. All right, so let's go ahead and start coding it. Let's do it in Python today. You can do it in other languages also, but in Java, the code becomes slightly longer because, of course, you're thinking about array lists. And when you're thinking about this type of a structure, it's basically a two-dimensional array, right? So in Java, it's like slightly more code or a little bit more syntax that you need to know, but it's also quite easy to do if you know array lists and their syntax. But for ease, let's go ahead and code it in Python. All right. So let's go ahead, and I am now going to go ahead and just create a two-dimensional array. And this is something I didn't explicitly state, but what are we doing here is when we are figuring out all the levels, we are figuring out the Pascal's triangle, which is basically a master array which contains other arrays as elements inside of it. In fact, even on lead code, if you look at this example, if the input is number of rows is 5, then the output is a two-dimensional array in which each of these levels or rows is an element. So it's an array with other arrays inside of it. That's why it's a two-dimensional array. And we will be building each of these levels specifically. So let's go ahead and get started. I might just call the array as a triangle. Okay, why not? So that's our main master array. And I'm just going to initialize this to an empty array in Python. And number of levels, I'm going to put n, and for the time being, we'll just say n is equal to 8 since we had that in our example. And now one thing to remember is if n was very small, for example, if n was only equal to 1, then you only need to add this. If n is equal to 2, then you'd have both these rows. So we should just make sure that we are putting the right number of rows. So let's actually do that. So if n is greater than 0, then we should definitely at least put the first array in, which is just a single value with 1 in it. So we're going to say triangle dot append, and here we go. We have a single element here, and 1 second. All right. And now if n was greater than 1, then we should also append the second row into it, right? So if n is greater than 1, then the triangle dot append, and we can put our second row. This is something that you don't need to compute, you already know, which is the first row and the second row, right? Now what we need to do is we need to go from I is equal to, let's see, I is equal to 2 all the way till 7, right? Because we've already got the first two rows. Let's go through the rest of them. So here we can basically put our for I in range of starting from 2 and going up to n. Now we need to figure out what we are doing. Now first we are making our new array, right? But we also know the new array should have at least one number right at the beginning, which is 1. So let's go ahead and create it that way. So we can say nums is equal to a new array with just a single number in it. And then as we keep calculating more numbers, we can keep appending to this array and then we'll go on. So let's actually write one comment here. We'll say add or append the numbers, you know what I mean. And then after we've done that, we also know that at the end we'll add one more 1 at the end of those numbers. So we'll go ahead and do that. We'll say nums dot append and we'll add another. Actually, that's it. Just append 1, right? So that is all we need to do. We need to now figure out what happens in the middle over here, right? So how are we getting the 2 and the 3, 3? And if you remember, this is what we need to figure out at I equal to 2, this is the number we are getting. At I equal to 3, these are the two numbers that should be in our array. So we need to figure out all these values so we can append them into nums just after the first one has been appended. All right, so let's go ahead. In order to find the sums of the previous array, we need to have a way to get the previous array. So the way to do that is you can probably have a variable. I like to call it prev because it means the previous array that was just calculated. And I can say, hey, give me the previous, which is basically I'm looking at the triangle 2D array and I want the I minus 1 value of that array, right? This is what I want. Once I have that, I can go through it and figure out the sums of every two consecutive numbers. So let's go ahead and do that. I'm going to go through this and I'm going to say for j in range. And what should this range be? Let's think about it. The first one should be 0. We are going from the first element. Now, we could say prev length of prev, right? We could do this, but let's see what we really need. In order to find the consecutive sums, for example, here, while my j is sitting here, it needs to figure out the sum of this and the next element. While j is sitting here, it needs to find the sum of this element and the next element. So I don't technically need to go to the last element at all because I don't have like some place where I need to find the sum of this and something else. So you don't want the j to go all the way from 0 till the end of this previous array. You only want it to go one less than the length of the previous array. So let's go ahead and do that change. Length of prev is basically if it was going till the end of the array, but we wanted one less. So I'm going to say minus 1 over here. Now we want to find the total of every two consecutive numbers. And I'm going to call it total here or the sum, your choice. Total is equal to prev of j plus prev of j plus 1. Okay, so that's what we are getting. And this is actually a good way to, now since we're only going till one less than the length, even the last element that you're going to will be fine because you will add that element with the next element, which is still around, right? However, if you went all the way till the end of the array, you would basically get some sort of error trying to get the next element. So this is the right algorithm. Now, you have got the total. All you need to do is you need to append it to the nums array. So I'm going to say nums dot append total. So far, so good. So I think this part is done, which is good. This is a good example of building a data structure where you kind of know a little bit at the beginning, you know the first two rows, and to get the future rows, you basically depend upon data that has just been calculated right before this, right? And we see this in all kinds of examples. And this is a really good example, and where you'll see the notion of a prev, or a previous data that you just have. One of the big things that we've kind of forgotten to do is, after we have built the array, now nums actually should have everything. We also need to add it to the triangle. So how do we do that? We say triangle dot append, and the whole array goes in as a new element, right? So we are going to say nums over here. And then at the end of this, let's go ahead and print the triangle. All right, so let's see if this will work. I'm going to click run. Let me see if I'm getting the right values. It seems like I am. So there's 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and so on. It does look correct, and we can even compare the last one. 1, 7, 21, 35, 35, 21, 7, and 1. And in this example, we have the same thing, 1, 7, 21, 35, 35, 21, 7, and 1. So this is how you can code the Pascal's triangle, and you can see how, this is slightly different from other problems you might have done. Some of the main points are that how are you finding the consecutive sums of an array, where you're not going all the way to the end of the array, you're only going one less, so you're actually able to get all the things without any errors. The other aspect is that you are making sure that you get a variable that is pointing to the element that was just created, the array that was just created, and that kind of, it's a good variable for you to even understand and remember that, okay, I am now talking about just the array that happened before this. You could have also used triangle I minus 1 everywhere instead of prev, but I think our minds, are able to think about a variable like prev more clearly. So definitely having some variables that, are easy to understand mentally is a good idea. All right. So that was Pascal's triangle for you. Let me see. I think I might have the code here. No, actually, I have it in a different language. Or let me see. Oh, yeah, I do have it here. It is in Python, and you can see it's put in here. You have to just tweak a few things in order to make sure that, it's like it's got a method here or a function, and you put in the code over here. It's pretty much the same. And let's actually submit it. It's very satisfying when we do that. So it was a good solution. It seems it is 100%, which is nice. And so it's a good runtime. And hopefully that was fun for you. And if you want to keep learning more coding, please, you know, keep following my channel, like this video, subscribe to my videos, and we can have more fun problems from Lead Code and other places in future. Thank you. Bye-bye.